Our team at Aurelius is tackling a major challenge in modern warfare, and that is how do we enable effective human machine teaming in environments with limited compute and disrupted comms? Our solution aligns to two crucible challenge statements for telecommunications and for autonomous systems. This challenge is specifically relevant for Group 1 UAVs. These are small drones, they're man portable, they're widely used by the Marine Corps, and today face severe limitations. Today, they rely on streaming heavy raw video to the operator for control. This consumes too much bandwidth, it introduces latency and delay, and it limits operators to controlling just one drone at a time. On the battlefield, these limitations turn into high mission failure rates. Even when successful, missions take more time. This increases the exposure of operators and warfighters at a time where they are potentially getting targeted. And on a broad scale, it limits our ability to scale up drone swarms. We aim to transform tactical drone operations with our platform, which introduces a new AI architecture that combines the strengths of onboard computing with the power of edge processing. With this new architecture, the drones execute simple AI tasks on board, like navigation, for example, and obstacle avoidance, while compressing sensor data significantly to send it to an edge server for advanced analysis. In this framework, we're not streaming heavy raw video to the operator. Instead, we're streaming a virtual representation of the real world that preserves all the details that an operator needs to make good, fast decisions without the rest. Our tests show that we can take images from drone cameras that are 600 kilobytes and take that down to just 10 kilobytes without losing any accuracy in object detection or depth estimation, for example, essential AI tasks for 2 and 3D mapping. If the Department of Defense adopts this technology in partnership with the manufacturers of drones, we can expect a range of benefits. Better, faster decisions in the field that leads to greater battlefield awareness at echelon, reduced risk for warfighters because missions are getting done faster, and with greater accuracy, we can get the warfighters out of dangers faster. And on a broad scale, we can expect to scale up drone swarms more cost effectively. Our competition is the status quo. The current AI architectures that force us to make a choice between two bad options, relying on suboptimal AI on board constrained drones or sending raw data over impaired channels that are constantly getting jammed. Our defense business is experiencing good traction. We're engaging with organizations like the Army Research Lab. Our business model, which is focused on partnering with defense primes to integrate our technology into their designs, is working. We have $600,000 worth of pipeline set to close in Q3. We're pursuing a wedge market that is significant, $75 to $100 million annually. And we believe the broader market for solutions that optimize for bandwidth and compute in an unmanned systems missions is both large and rapidly growing. And we have the right team to execute on this plan. A few highlights here. Our CTO and co-founder, Marco, leads the Intelligent and Autonomous Machines Labs at the University of California, Irvine, where he works with organizations like DARPA to advance research in distributed computing. He's the inventor of the technology. I've helped other AI startups scale and grow. In my last job, I helped an AI company scale from $2 million in revenue to $250 million. And then we have other people on our team that have supported programs of record for the Marine Corps, for example, and have extensive experience selling within the DoD. If selected, we intend to use the prize to develop a hardware demonstration for GIFIX in August, which is going to be focused on human machine integration. Thank you very much.